let's take a look at the traditional multiplication algorithm. And in student-friendly words, the old school method. So we are going to look at 2-digit by 2-digit multiplication, just as we have been looking at with the other strategies. And we're going to briefly look at what that will look like. So in the traditional algorithm is the only strategy that I was taught as a grade 5 student, and likely is the case for a lot of parents as well. And this is likely one of the more, definitely the more common method coming into grade 5. So although this is the one that parents are most comfortable with, so don't feel obligated to watch this particular video, but students, this might be more of a help for you, as I find that this one can get a little bit tricky. And the reason it can get tricky is because it is very important that we line up our digits so we get a correct answer. So in the traditional old school method is where we start with the ones column on the second factor. So we're going to take this 2, since we're always going to start here, and we're going to multiply 2 by 4, which gives us 8. We then need to multiply the 2 by the tens column and the other factor, which gives us 4. We go down to the second line, and we need a 0 for a placeholder. So I'm going to pause there, because this is often something that gets overlooked. And I know when I was first learning multiplication, this 0 nonsense just confused me. So the reason, if we were to ask a student, if we were to ask a young person, why does that 0 go there? One of the answers would likely be just because that is how it works. So the reason that I like to go back and look at this a little more closely is because we are multiplying the tens column. So this 0 down here is not just well, I guess it's a placeholder, but it's to represent that the 3 that we're multiplying is not actually a 3, it is a 30. So we look at 3 times 4, which is 12. It's not actually 3 times 4, though. It's 30 times 4, which is 120. So that's where this 0 comes in handy. Nonetheless, we have 3 times 4, which is 12. We need to carry that 1 up to the next column, because now we're multiplying 30 times 20. So 30 times 20 is 60, or 3 times 2 is 6. Plus 1 is 7. We add up all of those numbers together, and we have 768. I'm going to do another one using the same method. I'm going to go a little bit quicker in this one. We have 44 times 33. So again, we need to start with the ones column. It's always this. We set our anchor. We're always going to start in this place, regardless of how many digits we are multiplying together. So 3 times 4 is 12. Carry the 1. 3 times 4 is still 12. Add 1 is 13. 0 goes with the placeholder, since we're removing our anchor from over here. We're ignoring this one, and we're moving it over to the tens on the bottom here. 3 times 4 is 12. Carry the 1. 3 times 4 is 12. Plus 1 is 13. And we add these all up. We have 1,452. In class, we're going to be talking about the pros and the cons of using any of these methods. One reason that I choose to teach this one is because this is, like I said, likely the most common one, the most popular one to use when I myself am multiplying. This is what I do if I have a pen and paper. However, it's not the greatest when it comes to developing some number sense. So if I were to give you an example of that, let's say that we got a number that was totally out to lunch. So maybe we forgot to carry a 3 and we forgot to carry a 1, so it kind of messed up our answer. We really have no real way of knowing if this is a good estimate, if we know that this is a good answer, because we don't have that number sense. So I'm going to leave that one there. This is a great method, like I said, when I'm multiplying, when I need to do this math and I have a pencil and paper, that's exactly what I would be doing. However, the other methods that are going to be in this series will give you a different understanding of multiplication. So I'm going to leave that one there, and I will see you later.